Question 2b, we have hollow plastic hemispheres are created such that each successive one fits into the previous one because the radii are getting smaller and smaller, and we want to determine the sum of the outer surface areas, in other words the shaded part in these diagrams, if this pattern continues indefinitely. So indefinitely means the sum to infinity. So what I should do is try to get the first three areas. So the first area will be, let's call it T1. If I sub in the first radius, which is 21, and they've given me the formula for the area of a hemisphere, which is 2 pi r squared. So for the first one, the area will be 2 pi, the radius is 21 squared. And if I leave the answer in terms of pi, this will become 21 squared multiplied by 2, that gives me 882 pi. I now can work out the second area, so I'm going to sub in the second radius, which is 3 centimeters squared, and that's going to give me 18 pi. And for completeness, I'll do one more. So I'll get the area of the third hemisphere, so T3, that's going to be equal to 2 pi, and the third radius, it's actually a fraction, it's 3 over 7 squared, and again I will leave my answer in terms of pi. That's going to give me 18 over 49 pi. And if I now analyze the first three terms, you can see they have a common ratio of T2 over T1, which is 18 pi over 882 pi. The pi's cancel, and that simplifies to 1 over 49. So now I can use the S infinity formula for a convergent geometric series to be A over 1 minus R. A is the first area, which is 882 pi, all over 1 minus 1 over 49. And again, we can leave our answer with the pi in it. So that's going to be 1 minus 1 over 49. And if I work this out in a calculator in terms of pi, I get a final answer of 7,203, all divided by 8 pi. And this unit will come out in centimeters squared.